Welcome. Question 61. This is a little special type of question. Single block. See, a cable which passes over a smooth pulley is attached to the block placed on an inclined plane as shown. Is attached to the a cable. See, a cable which passes over a smooth pulley. The cable is attached to the block placed on an inclined plane as shown in the figure. Weight 10 kilonewton. This is the cable. See, cable stops here. See, now find the least value of force P this way to be applied to cable. See, at this point, as shown, to prevent the block. This block, only one block is there. This block from sliding down the plane. See, this angle is 46 degrees. Mu is 0.4. This angle is 41.8148 degrees. And here, see, the cable is parallel to the plane. But here, it is little inclined here, 18.3144 degrees with horizontal. I will tell you, some will wonder, sir, usually when they give question, they give 30 degree, 40 degree, rarely 34 degrees, very rarely 20.5, that way. What is this 41.8148 and what is this angle? Who will give this way? 18.3144 degrees. I have given to show you that this angle does not matter. This angle does not matter. It has no effect on the answer. Means when you solve, these two angles are not considered. See now, why? I will tell you reason why. Okay, start. As usual, don't see that side. First, let T be tension in the cable. In cable, as shown. Okay. Now, do one thing. Put this 18.34 degrees, some space it is taking there. See here. How much angle here? 18 point. See, I forgot now what is the angle. Okay, some angle given. Leave it. See, some angle given. 18 point something. I will tell you 18 point something. Okay. Now, when you apply a force P here, see, cable will be in tension like this. Here, like this. You write this sketch once again. See, you write this sketch once again here and write this is tension in the cable T. This is tension in the cable T. Now, correctly observe. They want to find the value of P. You first find tension in the cable. Then see what happens. See, first, as usual, force required for, see, they want the least value of P to prevent the block from sliding down. Therefore, this block will slide down, friction is up. I will not explain this one now. See, friction is up. Then, let R1 be normal reaction here. R, no R1, only one block, R. This is 0.4 R. Why? Mu 0.4. See, when you apply the force P here, this block is actually, this block will try to slide down. They want to find force P to be applied minimum force just to prevent this block from sliding down. So tendency of this block is to slide down, friction up clear. Later, when you consider equilibrium of the block, see some statement I will give later, you do one thing, this much you write and write. Consider equilibrium of the block, this block. R 10 kilonewton, 46 degrees. So this is your XX and YY, 44 degrees, tension T and FF. See, this 18 point something and also 41.8148, that will not come. When it comes, we will worry about it. Start. Sigma Fy0 plus R minus 10 sine 44 equal to 0. You will get R equal to, R will come 10 into sine 44, 6.947 kilonewton. 6.947 kilonewton. 6.947 kilonewton. Then sigma Fx0 take this side positive. Plus T, see, directly along the plane, plus 0.4 R minus 10 cos 44 equal to 0. Now I should not explain. It will be insult for so many if I explain now. Substitute whatever R you got T. T will come 6.947, that is R into 0.4 equal to into minus 1 plus 10 into cos 44. 4.416 kilonewton. 4.4155 kilonewton. Okay, R will come plus 4.415 kilonewton. Now do one thing. Once you get here, you write here. See, answer. See, when you consider the cable here, see what statement I am giving you are right. When you apply the force P here, this cable will be in tension. These are collinear. See, irrespective of that 18 point right here, that given angle of 18 point something does not matter. If you apply a force P this way, cable tension is T, right? P will be equal to T. Or whatever force you apply here will be tension in the cable. Therefore, right here, least value of P required to prevent the block from sliding down is whatever T, 4.415 kilonewton. Over. Question is over. That's all. Now, question 62, what I will do is here. Same question I will solve, 62. This time, see, I will once again give 41.8148. This angle I don't remember. Okay, I'll write here some other angle now. Anyway, 18.646 degrees. And here what I will do is, see, P. See, I will see that the cable will come, see, the cable will come this way. This way it is. See, this is the cable. If the cable goes this way, or neatly I'll write here, see, the cable will go this way. It is not attached parallel to the plane. It is inclined this way. Okay. Now they will give the angle here. See, this cable makes an angle of some small angle with the plane. See here, I am showing parallel to the plane. This angle, space is not there. I will write some 12 degrees. 12 degrees. Okay. That remains same. This is 12 degrees. Means this is, last time this was parallel to the plane. Now it is inclined at 12 degrees. See here, clearly 12 degree angle. But now I will change the question. Last time they want P to prevent the block from sliding down. Now I will ask, find the value of force P to be applied to the cable as shown to move the block, up the plane. Okay. Now right here. Now also solution. See, again this angle is not required. Where is the block here? This angle also not required. But this 12 degree, see, make a note here. This 12 degree is very much required. Very much required. Very much required. Now, once again, write as usual. This all remove it. Remove all this one. Write the statement. Limiting friction FF. Let R be the normal reaction. Limiting friction. That is FF limit equal to coefficient of friction into R. Friction coefficient is 0.4. So 0.4 into R. All you write. But remember now they want the force P to be applied to move the block up the plane. See, up the plane. Since the tendency of P is to move the block up the plane, what will happen now? Your friction will become down. Down. Okay. Now then, also, see, you write one more sketch here. Show tension here. See, tension T. Show here, tension T. Right, neatly mark. This tension T now, it is not like this. See, with the plane, I show green color. See, with the plane, the tension T is acting. It is actually this way, see. T is like this. It makes an angle of 12 degree with the plane. So now, see, I forgot last time with the 44 degree, I actually not required, you know it, cos sine. I forgot right last time. Now see, you resolve here. This will go along the plane. This will go perpendicular to the plane. This is cos, this is sine. Now, the cable is inclined here. See, that side inclined, nothing to worry. It does not matter. But this side inclined, it is connected to the block. What angle it is connected to the block counts, because when you consider equilibrium of the block, this T will come. That T will be equal to P. You see, you take the cable like this or like this. See, you take this way or whatever way you take here. Smooth hinge. You had one more statement. Since the cable passes over smooth hinge, smooth pulley, tension remains constant as usual. This is all I told. Those who are not studying properly, it is their problem. It is not first time you are doing. Okay. Now, this is the case here. See, start. This I will remove now. This is gone. See, sometimes become too lazy to search for the cloth. Okay. Now, I will write here. As usual, let T be the tension in the cable. Start. Sigma Fy0. I write here. Sigma Fy0. Take upward positive. Okay, start. Plus R. I am going to do one thing. Since you want unknown is T, start from T. Plus T sine 12. Red color. See why unknown. Our import unknown. Plus T sine 12. T sine 12. Then plus R minus 10 sine 44 minus 10 sine 44 equal to 0. You call equation number 1. Sigma Fx0. Take right side positive. Then you get plus T cos 12 plus T cos 12. These all explained thousands of times earlier. Plus T cos 12 minus 0.4 R. Minus 0.4 R. Then minus 10 cos 44 equal to 0. Equation number 2. Solving 1 and 2, you get the value of T. T will come in kilonewton. Now, very important, I should not tell, when you solve 1 and 2 using calculator, this should be taken to that side. Otherwise, it will give wrong answer. That much common sense required. See, calculator is A1x plus B1y equal to C1. See, those things all I cannot tell in the class. So, mode alpha A. See, I will show you how I am solving. Simultaneous equation. Two unknowns. First coefficient is cos 12. Okay. Second coefficient is minus 0.4. Next coefficient, this will go that side. 10 into cos 44. Second round. Okay. I put this equation first. Okay, no problem. Next, other one, I should interchange. No problem. See, sin 12. Next one is 1 and 10 into sin 44 over 9.396 kilonewton. 9.396 kilonewton plus you require more effort now, kilonewton. Then write whatever tension in the cable T is the force P. See, whatever tension, whatever force you are applying T, therefore least value of force required P to move the block up the plane is 9.396 kilonewton. Over. 2 questions solved. Actually, one information, not in big information. I am going to native place where there is no recording provision. So now it is late night. Tomorrow early morning I am leaving. So today what I am doing is just to see that there is no discontinuity. Short classes two questions class I am uploading. I will prepare, that is for tomorrow's class, next day class and next day class. I will be out of station for 3 days. So for that reason, I am right now recording for all the further classes. Okay, therefore, I can do one more question, but time is not there. So this is question number 61, 62. Next is 63. This will be coming up in the next class. Okay. Thank you. We will meet in the next class.